Alright, so translating functions is not so bad. We'll start with this just base function, y equals x squared. That is a square function, forms a parabola, and we'll translate this in various ways. So I want to show you what happens with the equation that to produce these translations, and then we'll kind of go the other way too. So translation is a transformation, a change of the graph in which the entire function is shifted, and the entire graph of the function is shifted upward or downward, so vertical translation, or it can be translated horizontally, so you can shift the whole thing to the right or to the left. And of course, you can do any combination of those. Up and to the right, down and to the left, up and to the left, etc. So let's look at how the equations would change to show those kinds of translations. So let's look at the vertical ones first. If I wanted to shift this whole graph upward, I would say y equals x squared plus 2. So that's a vertical shift of 2. You can see, if you look at x is 2, 2 squared is 4, but then I would add 2 to get 6. So this whole thing would be shifted up. And that would be the case for every point of x. Like 0. 0 squared is 0, plus 2 is 2. So that thing would shift up. So take all the points and shift them up by 2. So as you might expect, a vertical translation downward would be x squared minus 2. Downward shift by 2. And then the horizontal translations would happen inside the function. So if x squared is the function, we have to go ahead and directly modify the x within the function. So for example, like this, we'd say x, so we'd put that shift on the inside, x minus 2 squared. Now that would actually be a translation of 2 units to the right. You might think left because it's negative, but let me show you why. If take, for example, the point 2 again, 2 squared is 4, but if I've got x minus 2, it'd be 2 minus 2 is 0, 0 squared is 0, so I'd be down here. So this point, in essence, would move 2 to the right to there. Or let's look at another one. 3 squared is 9, so here, but this would be saying 3 minus 2 squared. So 3 minus 2 is 1. 1 squared is 1. So this point would be here. In other words, this point would move 2 to the right here. 1, 2. Okay, so x minus 2 squared would be a horizontal shift 2 to the right. So as you would expect, x plus 2 would be a shift of 2 units to the left. And then yeah, so okay, I mean let's just graph one of these. In fact, I'll just copy this curve and make another color. So we could do a shift upward of 2. So I would just take all my points and take their y coordinates and add 2 to them. 1, 2. So this point plus 2, this point plus 2, this point plus 2. I could just pick out some easy points where that's easy to see. This point plus 2. That's the shift upward of 2. Downward by 2. Be like that. X plus 2 squared would be like that. Shift over to the left of 2 units. And x minus 2 squared would be like that. Now let's just draw a random curve on here that represents some kind of bizarre function. So we've got a graph of a function. Let's call it g of x. That's g of x, right? Well, what if I were asked to graph g of x minus 2? Let's say x minus 3, mix it up. That would be a inside transformation, so it's horizontal, and I would move it over to the right by 3 units. So I will copy this and make it a different color to show you. Now, of course, if you're doing this by hand, you could just take a few points and then plot a new point. So I'll just do that. So take a point that's easy to see where it is, and then move its x-coordinate over by 3. 1, 2, 3. So that little peak thing is going to be over here now. See, this little peak thing is going to be 1, 2, 3 over here now. This point will be roughly over here now. So all together, when you did that for a few points, it would look something like that. You just move straight over. Something like that. Now, on the other hand, if I wanted to get g of x plus 1, that would be a vertical translation. So it's outside the function. And I would just take some x-coordinates, or take some points and take the y-coordinates and just add 1. So take that y-coordinate, add 1. So that's a little valley there would move up 1. That little peak there would move up 1. I'm just picking some points that are easy to see. This point would move up 1. So copy this, make it a different color, and then the whole thing would move up 1, something like that. Alright, so let's put this together. Say like I had the function y is equal to x minus 3 cubed plus 7. Well, I can see from this that my original function, like sort of my base function where I can base everything off, is x cubed. So I could graph x cubed. Here, the inside transformation, x minus 3, means that I move this to the right 3 units, and then my vertical says I move the graph up 7 units. So I could graph this first, and then take those points, shift them over by 3, and shift them up by 7.